Welcome back to the Computer Hardware and OS Essentials lecture series. I created these custom lectures based on A+ certification program, but with few enhancements to improve your IT technical skills and knowledge. So if you haven't seen my previous videos, I will post a link in the description for the playlist. This would be our 10th lecture in which I will cover network systems or networking. The primary objectives of this lecture is to cover basic fundamentals of network systems, introduce you to network types and internet connections they use, configuration and security options of a typical multifunction router and a modem, and some basic Windows-based troubleshooting guidelines. Are you interested in network engineering? In this A+ based lesson, what I'm going to do is I'm going to cover a broad overview of network systems, but I will not go into any high-level details and in-depth analysis of how network systems and engineering works, because that is not part of your A+ certification program. But however, you can get more in-depth knowledge with my other lectures with respect to CCNA that has already been posted to my YouTube channel. I will leave links in the description for the CCNA 1, CCNA 2 and CCNA 3 playlist. Those are 3 different courses that you can take on my YouTube channel that is associated with Cisco Certified Network Associate program. I have multiple videos covering different modules that will enhance your understanding about network engineering on top of what you are going to learn today in this lecture for your A+ certification program. So again, in this lecture, in this lesson, what we're going to do an overview, a broad overview of network system, but we will not go into depth of network engineering because it is not part of the A+ certification program. But I would recommend that you go ahead and watch it on my YouTube channel on CCNA videos to get a much better comprehensive understanding about what we're going to cover today. So having said that, let's look at types of networks and network connections. Networks can be categorized by technology used and the size of the network. For example, PAN, which is a personal area network, consists of personal devices such as cell phone and laptops. LAN, which is known as the local area network, covers a small local area such as a home, office, or other building. So here's one place that some A+ students get confused about. So if a LAN is a area that covers a small office or home, so what's the difference between a LAN and a PAN? So if you have a Bluetooth device that you are connecting to tether internet across, that can be considered as a PAN. So that small consists of your personal device and the cell phone itself that is tethering the cell phone to your laptop. That is type of a PAN. So that's what makes it a PAN. But your laptop, if you connect that to your local area Wi-Fi network or Ethernet cable, that laptop is part of the LAN, which is the local area network. So that's the difference between a PAN and a LAN, if somebody asks you that. WMN, which stand for wireless mesh network, covers a limited geographic area and is popular in places where cables are difficult to install. So the advantage of wireless mesh network is that you have a bunch of components that work together in tandem to build a wireless network infrastructure without the need to having specialized equipment such as access points that would be directly communicating with a central device. So instead of having a central device, the mesh network would be bouncing off each other's devices. So you can have multiple mesh devices interconnecting to create that network space. MAN, which is the metropolitan area network, covers a large campus or a city. And WAN, which is the wide area network, covers a large geographic area and is made out of small networks. So the WAN could be categorized as something that usually handled by your ISP, or if you work for a company that have multiple branches that could in multiple different cities, that could be a WAN connection as well. The MAN examples would be if you have a large campus, for example, a university, or a large organization like a large corporation with multiple buildings, that would be connected through a type of MAN. So they will have LAN inside the building or each floor, and then a MAN will be covering those different buildings together. Please keep in mind, in this lecture, we are trying to focus on A+ certification program, and therefore I will not go into in-depth analysis of PAN, LAN, WMN, MAN, and WAN. However, we will cover concepts related to this that is associated with the A+ certification program. So if you look at the broad overview which I just described, this is what it is pretty much. So you have the nano, which is the smallest, then we're going to get BAN, PAN, LAN, CAN, MAN, RAN, and WAN. And each time it's going to get bigger, the area that's going to cover going to get bigger. In this diagram on the right hand side, we have the PAN, which is around a person. As I mentioned, it's like having a cell phone, Bluetooth connection being used to tether or lock into a laptop and supporting tethering, or even Wi-Fi. Hotspots are considered as type of a PAN. And then LAN would be the 10 meters, 100 meters, or even up to a 1 kilometer can be a LAN, can be a LAN too. Basically, what define a LAN is the administrative area, I would say, which is the building floor or your home, for example. MAN, it could be like tens of kilometers, and the WAN is thousands of kilometers. So that's how you can look into those different types of network connections. Key internet technical terms that you should be familiar with in A+ certification program includes the Internet Service Provider, which is shortened ISP, that is used to connect to the internet. So they are the providers of the internet for multiple different parties, with the home users, enterprise users, business users, etc. The most common type of connections are DSL and cable internet. That's where the DSL modems and cable modems comes in. In Canada, the most commonly used type is the cable internet. However, there are parts of the world still do use the other types of connections, such as the dial-up, due to availability issues. Even in Canada, in rural parts, they still use some dial-up internet connections, but most commonly in modern day, in most countries, they use DSL and cable internet. And the reason being, the prices have significantly come down with in terms of cost associated with building these type of infrastructure. ISPs devote more available bandwidth to downloading as opposed to uploading for most of their consumers, like 99% of consumers. The reason for being, when you are surfing the webs, or whether you are downloading a movie or a file, or whether you are watching this YouTube video on youtube.com, most of the bandwidth goes into downloading data, not uploading data. So ISP typically almost always prioritize download bandwidth over upload bandwidth. The bandwidth is a measure of maximum data transmission rate that is also being used to market different packages of internet by your ISP. Data throughput is the actual network transmission speed. So don't get confused between the bandwidth and data throughput. The bandwidth is a measure of maximum data transmission rate, while the data throughput is the actual network transmission speed. Latency is a delay in the network transmissions, and latency is measured by the round trip time it takes for a data packet to travel from source to destination and back. So that's the definition of a latency calculation. Latency is a very common term that being used, a matrix that being used in enterprise and business environment when we are testing server connections, for example. But latency is also very popular among consumers with respect to gamers and other users who need that low latency. So if you have a jitter when you're playing games, that may be caused by latency. So you may have heard that term a lot. Quality of service, or QoS, is the description or measurement of the overall performance of a service by assigning priority to traffic. So what that basically means, if you have traffic, the web traffic, you have video traffic, and you have voice over internet traffic. Voice over internet traffic is time sensitive, but not the web traffic. So you can give priority to voice over internet traffic, so that you can give the priority to that type of data transmission, that type of packet to be switched before somebody who is searching web on the same network. Again, if you would like to learn in depth of how QoS work, I have already explicitly explained how these concepts in advance on my CCNA lecture series. So please go ahead and watch those CCNA 1, CCNA 2 and CCNA 3 lecture series on my YouTube channel, and that will give you a more comprehensive understanding about QoS. The demilitarized zone is another term that you hear with respect to routers. And it is also known as DMCs. Those are physical or logical subnetwork that contains and exposes an organization's internal facing services to an untrusted, usually a large network such as the internet, or placement of items such as web hosting or FTP servers. So for example, if you want to host a website even at your house, and if you have the certain ports available open, or your ISP have some type of way to have an agreement where you are allowed to run a web site out of your house, you can put your web hosting server in the DMC. For example, I'm with Shaw Cable in Canada, and I have an agreement with the Shaw Cable, with the management team, the consumer relationship team, that I'm allowed to run some web application off of my home because I'm a student, and I used to be a student, and now I'm a network specialist who have to use those kind of things. So what I do with those servers is I put it in the DMC, away from the firewall rules and other items that I have set up, because that will be exposed to the public. So the DMC is basically what it actually stands for, demilitarized zone. So technically all the security features, or most of the security features, have been taken away from the items such as servers located in that DMC zone. Internet connectivity types. So each of the following technologies have unique set of configuration methods, capabilities, features, and limitations. So internet connectivity types include the analog modem, ISDN, which stands for Integrated Services Digital Network, cable modems, DSL type modems, satellite modems, fiber, wireless connections, Powerline networking, cellular network, and dial-up. I'm not gonna cover all of these items today, but you should know these items exist. So I'm gonna go broad overview, but I will cover some of the items such as the cable, DSL, satellite, fiber, and wireless. But I'm not gonna cover everything, all today, because it's not necessary for this particular course. Modem versus ONT. A modulator demodulator, also known as a modem, is a computer hardware device that converts data from a digital format to a format suitable for an analog transmission medium such as telephone or radio. And therefore the modems are used in dial-up, cable, and satellite internet services. And this is basically like pretty much a demarcation point between your ISP and the internal systems, right? So your LAN network. Demarcation means basically separation between your ISP and what you own, right? Your LAN is owned by you, and the internet network, the WAN, is owned by your ISP, and the modem typically act like the demarcation point. Fiber doesn't require a modem. Instead, it uses an ONT, which is short for optical network terminal at each endpoint. The reason why fiber doesn't need a modem is because it uses a different technology, completely different technology to communicate, and it does not require that type of modulations in order for the data to be transmitted. So it's going to be using light as a source of transmission. Light is the one that used in fibers, right? So You can consider the ONT as a fiber modem, but technically it is not a modem. So on the right hand side, for example, this is a fiber ONT. So it looks like a modem, but it's not. So you have the fiber cable coming in on this right hand side, and then you have the network connection you can use coming out of that ONT point right here. This is a cable modem. So you have the coaxial cable coming in and connecting to this cable modem right here, and that will give you again RJ45 network connection out, just like the fiber ONT did, but except this is a modem, this is an ONT. So keep that in mind. So there is a difference between modem and ONT. Where the fiber ONTs does not modulate anything, it just act like for that particular purpose. Again, I'm not going to go into any depth of how exactly ONTs work in this class, because that is not needed for your A+ certification program. Cable internet and DSL. So if you compare the cable internet and DSL, they're very similar to each other, because both of them are kind of always on type of connections, as opposed to, let's say, dial-up connections. And cable internet uses existing TV cable lines and is always connected, so always up. And the TV signals and PC data signals share the same coaxial cable, and cable modem converts PC's digital signals to analog and converts incoming analog data to digital. So the primary purpose of a cable modem, which is how it modulates, is it converts the PC digital signal into an analog signal, and then incoming signal is going to be analog on that cable, and then that will be converted back into digital for your PC to consume. So that's how the cable modems work. If you have both TV and internet connection, that one single cable connection can provide both. In my house, we don't have TV because we don't watch TV on cable, so we just have cable internet. In that case, that line only using cable. DSL, as opposed to cable, stand for digital subscriber line, which is a group of broadband technologies that covers a wide range of speeds and uses ordinary copper phone lines and unused frequencies. So on the phone line cables, when you're talking to someone or when you're using your telephone, it doesn't use all the frequencies available on that wire. So all those unused frequencies are now utilized by the DSL to transmit internet packets. It is also an always connected type, just like the cable internet, and can use the same telephone line for voice and DSL at the same time. Sometimes those type of DSL mechanisms are advertised as XDSL, which refers to various types of DSL, which ADSL, which stands for asymmetrical digital subscriber link, or asymmetrical DSL, being the most common type used today. ADSL uses faster downstream speeds than upstream, just like I mentioned before, but there is a significant difference between the downstream than the upstream speeds compared to maybe cable, for example. Cable also has the much higher downstream speeds compared to upstream. So download speed is always going to be higher on all of those internet connection, but the DSL maybe a little bit more pronounced. Dedicated line using fiber optic. You may have heard the terms such as fiber to home, fiber to site being advertised by Canadian companies such as Bell, Telus, Rogers, and Shaw Cable, and all of those people, those marketing people are talking about is a dedicated line using a fiber optic. So it used to be really expensive and it is cost prohibitive for a home user to have a fiber to home, but now the cost have again significantly come down, but not as cheap as the cable internet, but it's still better than what it used to cost a long time ago. Fiber optic is therefore a dedicated point-to-point, also known as PTP connection, and there is no line sharing like in the cable networks. You may be sharing with a bunch of other people the same network. That is called the cable loops. So if the loop have a lot of users with high bandwidth usage, that may actually slow things down. So in the cable internet, one of the problem is that especially in neighborhood at night time, maybe the internet may be a little bit slower than the daytime when nobody's around at home in the neighborhood, for example. But that's not the case in Canada nowadays, because the bandwidth allocation is huge, that I, at least not in my house, I never feel anything slowing down. But it is still a problem, a little bit of a problem with the cable internet. But with the fiber optics, it is a dedicated point-to-point line, so there is no sharing with anybody else. That you can, just like the cable, you can use the fiber to do television, internet data, and voice communication using the same fiber optic cable with no issues at all. Again, upstream and downstream in this situation, typically the downstream is bigger than the upstream capabilities. However, it varies with the price. So if you are willing to pay a higher price for your fiber optic connection, you can get the same upstream speed as well as the downstream speed. In other words, you can get the same upload and download speed. I don't know why anybody wants to do that unless you are hosting a whole bunch of servers in your house and you need to connect those to the internet. But when it's come to point, if you are working in an enterprise or a company environment where the company may need higher upstream speeds or upload speeds, a dedicated fiber line would be the best choice. The cost is generally higher than the cable and DSL, but offers cheaper than satellite internet in most parts of the world. So it is still sometimes cheaper than the satellite internet, but it's gonna be more expensive than the cable and DSL. So again, if you are in a large enterprise environment, such as large businesses and enterprise environments or large campuses, you are most likely will be working with fiber optic lines as opposed to the DSL or cable. But most likely, if not the fiber optic, it's probably going to be cable in most situations, whether it's campuses, universities, large scale businesses, enterprise environments. Most likely you will be working with fiber optics at this stage of time in 2022. Satellite internet. So the satellite connectivity requires a satellite dish and a satellite modem at minimum. So fiber has ONT, and the cable and the DSL also have modems, and the satellite also need a modem. And it also may require an analog modem and other equipment depending on satellite provider. Higher the cost compared to the cable and DSL internet, but provides flexibility for rural and remote regions of Canada and many other countries. So here in Canada, we have very rural sites, especially in northern Canada, and almost most of the time those homes and businesses would be using satellite internet. The reliability of satellite internet depends on weather, cloud cover, and a few other factors sometimes. For example, electromagnetic waves, and not really electromagnetic waves, like the global certain weather conditions can have an impact on the satellite internet. Poor weather conditions, like especially in the up north in Canada, like in Yukon and Inuit, like for example, very high up in the Arctic, there may be some issues with the weather conditions. Even in the major cities like Edmonton, for example, there may have some situations where the reliability of satellite internet may fluctuate as a result of weather and cloud cover issues. The satellite internet can reach similar bandwidth, but may have higher variation in latency. So depending on how good your satellite dish can lock into that satellite, your latency may change. So for example, the satellite that you're locked into right now may be different from the satellite you may be locked into 5 hours from now. So the latency and the bandwidth can dramatically change. The latency could dramatically change, but the bandwidth should be similar based on your package actually. Yeah. So that's how the satellite works. And keep in mind, the satellite requires a line of sight wireless connectivity, and latency often is more pronounced when uploading as opposed to other internet connection options. Obviously, ADSL and cable internet also have lower uploading speeds compared to downloading speed, but the latency is minimal. But here the latency may be more pronounced. So on this diagram on the bottom of your screen, you see how typically how these satellite systems work. So your internet service provider will have a network connection. So NOC stands for a network operation center. So that's where all the connections comes in to your internet service provider. They do exist in cable and modem, cable modem and ADSL and fiber networks as well. So they all have NOCs. And then the NOCs have in this situation, a very large satellite that is communicating with a satellite dish that is communicating with a satellite. And then that satellite then get connected to your satellite dish, which is going to be a small consumer grade satellite. And then through a satellite router, you can use that for different various purposes, from video, audio, just web browsing, VoIP, etc., etc. Dial-up internet. Dial-up or post, which stand for plain old telephone service, is the least expensive and however the slowest connection to the internet. A modem, which is a modulator demodulator, connects a computer with the outside world through a phone line, frequently called a dial-up network because the modem uses the traditional phone line to dial in or dial up or call another modem. So basically you are dialing to the network, dialing up, just like a telephone. Modems can be internal or external on devices. So you can have this is a dial-up internet card, because nowadays most of the desktop computer motherboards do not have dial-up connection. So you can add a card like this and still use some areas of the world, and it is still in use in some areas of the world, especially in developing countries, but also in developed countries like Canada, as I mentioned, because some rural areas may not have the infrastructure for those cable or fiber optic systems. In terms of reliability of dial-up, it's going to be kind of similar to that of satellite, but I would say, yeah, the reliability would be okay. But it's not the reliability the issue. The issue is the dial-up part and the slower speed, because you will be using a telephone line to connect to the internet. Cellular WAN internet. So a wireless wide area network, also known as WWAN, or is also called a cellular network or cellular WAN, which covers a wide area. That's what the purpose of WWAN. It is made out of cells created by base stations. I will show you a diagram on my next slide on what it, typically how we represent that. A base station might include more than one transceiver and antenna on the same tower that will support multiple technologies. So what's going to happen is you will have those cell towers, and they will have multiple transceivers and antennas connected on that cell tower, attached on that cell tower, and some of those cell towers are shared by multiple service providers. So Bell, Telus, Rogers, they all may be using the same cell tower, and from that base station, you can create these cells, right? And that's how they connect to your cell phone. And two established cellular technologies in Canada and worldwide are GSM and CDMA. GSM is the most commonly used type right now, and long-term evolution, also known as LTE, and voice over LTE, also known as VoLTE, are expected to ultimately replace those GSM and CDMA bands. As well as, remember, there are different technologies on transmission of data across this type of wireless medium, which include like 3G, 4G, and now we have 5G, for example, and we are even moving into 6G maybe at the end of 2023. Who knows? We are getting closer to going really high up in terms of bandwidth. To connect a computer using mobile broadband to a cellular network, you need the hardware and software to connect. And for the most network, a SIM, which is stand for subscriber identification module, that's what the SIM stand for, card. So you need a SIM card that is capable of handling mobile broadband and has to have those packages activated so that you can connect your cell network to access the internet. So options for software and hardware devices that can connect to a cellular network include embedded mobile broadband modem, cell phone tethering, USB broadband modem, LTE install internet, and mobile hotspot. Very popular choice with increased use of the mobile devices by both businesses and consumers. However, typically they are slower speeds and bandwidth than the comparable cable and ADSL connections. So on here on this diagram, it shows that each cell tower will be creating a cell around it. So that's why we call it a cell phone. So when if you are a user and you're traveling, let's say like this across like that, and each time you go into one of those cells, your cell phone will hand over the connection to the next tower. So if you are driving across like this, let's say, right, that it will be handing over from here to here to here to here to here to here. So that's how it just basically handing over between different cells or cell towers. That's how we call it a cellular network. So the towers look like these. These are the different receivers and antennas that I mentioned in the previous slides, and they will have these kind of type of connections and antennas, and all the cables associated with it will be in there as well, and they get fed to the bottom base of this tower, and on that base all the equipment associated with these antennas and receivers to run will be placed there. Then they usually have power backup as well in case of a power failure, because you don't want to take out a whole bunch of cell communications because the power goes out. And it has other security features and safety features such as lightning arresters, etc., built into it as well. And on the cell phones, this is probably more familiar to you guys nowadays, which will have a SIM card. In the old cell phones, where you can have a removable cover, the SIM card is right behind the battery. But the new cell phones, you will get a SIM ejector tool, which you push into a small pinhole, and that will pop up the the SIM card holder, and that's where you will be putting the SIM card. And keep in mind, some cell phones do offer dual SIM capabilities as well. And here's a type of a WAN connection. This is like a MiFi or tethering type of network communication system. And this one is a AT&T branded system. It might have a SIM, it might not, maybe it's built-in SIM, built-in programming. And what this does, actually, this directly connect to a cell network to provide internet connection to this laptop user, or you can plug this into a desktop as well. It works through a USB, and this is most likely going to be a type of like a MiFi device. So what's a MiFi device? That's what we're going to talk about next. So tethering and MiFi. So tethering, or phone as a modem, also known as a PAM system, is the sharing of mobile device internet connection with other connected computers. So your mobile cell phone already have an internet connection through your mobile network, but with tethering, now you can share that internet connection with other devices around you. So the cell phone creating a hotspot for other devices to connect using a Wi-Fi standard is called tethering. Novatel Wireless owns a registered trademark on the MiFi, which stands for Mobile Wireless Fidelity, brand name in the United States. And this is a very common term, just like we use the term Kleenex for wiping clothes, like the paper wiping clothes. In Canada, we often call it Kleenex, but it's actually the brand name. So MiFi is not a IEEE certified wireless communication system. It's a specific trademark name. It stands for Mobile Wireless Fidelity, and it is used for wireless internet connection based on cellular network, and creates internet connection anywhere in the world as long as there is a cell signal available. So keep in mind, it is not a standard, but rather a brand name, and they look like these. So these are like small devices like this, and it can be powered either by a USB cable connect to a wall, or some of them also have battery power, and you turn it on and it connect to a 4G, 5G, 6G networks, and that is called a MiFi device. That is then gonna create a a wireless system, a small mini wireless infrastructure, so that you can connect devices around to it to access the internet. So please keep in mind that MiFi is not an international IEEE standard as far as 2022 goes. It may become a standard in the future. It is a particular trademark registered, but however, it acts just like a tethering device, like a tethering cell phone, but provide maybe greater capabilities in some situations, because it's specifically designed for that specific purpose of accessing internet through a cell network. Local area network, or LAN. Common communication line or lines within a distinct geographic area is called a local area network. So if somebody asks you what is a local area network in your A+ certification exam, it is a common communication line or lines within a distinct geographic area is what is the fundamental definition described by the A+ certification program is called a local called a LAN. So if that is the definition for a LAN, this exam question will come up. It always did, and it will come up. What is a LAN? This is what it is. It's a communication line or lines within a distinct geographic area. Network connected devices in home, businesses, and enterprise environments. That includes the servers, desktop computers, laptops, wireless devices such as Wi-Fi connected devices, in other words, printers and other devices, switches, routers, firewalls, or other network components within your network infrastructure. Behind that behind that demarcation point, as I mentioned before, it is considered as part of your LAN network. So behind your modem, your router, your switches, your firewalls, and everything else will contain within behind that modem, which includes the servers, computers, any end devices, printers, everything is connected. Network connected devices are part of the local area network. LAN is the responsibility of local IT team or contracted IT service providers. So in other words, demarcation point, which is a term first used in PSTN to describe the separation between the service provider's responsibility and the end user's responsibility, is the point where the responsibility split into two areas. So as I mentioned multiple times on my previous slide as well, the demarcation point is a point where your internet service provider's responsibility ends. So typically it's at the modem or at the router. So sometimes modem router combination. So most home users may get a internet modem router combination. That modem router combo device would be the demarcation point, and whatever behind that means whatever inside your house gonna be the LAN, and that is your responsibility. It is, if you are a home user, it is your responsibility to manage that. Or it would be the local IT team for a company or enterprise environment, or it could be a contracted IT service provider that your company has to hire from outside IT services to manage it. With respect to home internet connections, some ISPs in Canada, they will actually support you if you have any technical issues within your home, because they are trying to sell a service like internet service to someone who doesn't necessarily understand how technologies and internet systems work. But typically the demarcation point is where the responsibility is split, right? So keep that in mind. Packet switch IP networks. So there is a difference between packet switch IP networks and the regular PSTN network. So the PSTN network is the one that we use for our cell phones. PSTN network is the network that we use for our voice communication using traditional telephone lines. The packet switch network is completely different. And if you want to know how packet switch network, which is what we use for internet, and VoIP, for example, there are many videos posted on my YouTube channel, so please go and check my CCNA videos, and that will give you some comprehensive understanding about that. Connecting to a LAN via wired or Wi-Fi wireless. So to connect a computer to a network using a wired or wireless connection, you need to follow these basic steps that A+ certification program have described. Those include making sure that you install the network adapter and drivers. And for wired network, you're going to connect the network cable to Ethernet RJ45 port and network port, which we have described in my previous lecture. So if you don't know what the RJ45 look like, or what the ports configuration looks like, please go back and onto my YouTube channel, watch that previous video. And we need to verify the connection is good. And the easiest way to do this is actually look at the lights. Like for example, some network cards, if it has a full gigabit connection, it will blink in green. And if it has only 100 megabyte connection, or there's a connection problem, it's going to blink in orange. And some network cards actually tells you, depending on how often it blinks, they may have some problem. So they may be able to actually indicate there's a problem by just blinking lights. So verify the lights are turned on when you plug it in, and Windows should automatically configure the connection. So if you have the DHCP going, which is the dynamic host configuration protocol, which I will talk about a little later in this lecture, once you plug it in to a LAN connection on a LAN network environment, you should automatically connect and get all the IP addresses, and you should have access to the network and the internet. It's very simple. Authentication is a different thing. Authentication is like, it's different for logging into wired networks. Sometimes do require authentication in enterprise environment, but you will still have the network connections. So just plug it in, it should work. For wireless network, you need to click on the network icon and select a wireless network and click connect. So if you look at the Windows computers, you can go to the network icon, and then it's on the bottom right hand corner on the taskbar, and then you pick the wireless network you want to pick, and then you click connect. And if the network is secured, you must enter a security key, which is the passphrase or the password that you're gonna enter to connect to that network securely. So if this is the first time you have connected to a local area network, you will be asked if you want to make the PC discoverable. So you'll see in that blue screen on Windows, I believe Windows 8, 9 and 10, they all had type of screen. Maybe Windows 10, it was a black screen. So it will pop up on typically the right hand side and saying, hey, you just connected to a new network. Is this device should be discoverable in this network? You can say yes or no. So for the private networks, obviously you can click yes and it shouldn't have any big issue. But if you are on a public network, always select no. So that way that, if you're on a Starbucks network, for example, Starbucks open Wi-Fi or something, or Home Depot open Wi-Fi or something like that, you don't, give out your personal certain information, because making it discoverable may be opening up more opportunities for someone to discover your private internet networks, private data, right? So keep that in mind. So it's a security risk if you say yes on a public network. So the next step number 4, open the browser and verify the internet connectivity. And for some hotspot, an initial page called a captive portal appears, and you must enter a code or agree to terms in order to use. This is a very common type of security and access control used by places like hotel rooms, like hotels. So if you go to a hotel or even an airport, and when you connect to their open Wi-Fi network, as soon as you open up the very first page, you will get into a captive portal, and you sometimes have to click agree to their terms of use, such as abuse of internet, unethical use of internet. We are not going to do that, and you're going to say yes, and then you will be able to access the rest of the internet. And in some cases, you may also need a password or a security code in order to get access across that system. So that is what we call a captive portal. So captive portal happens after you connect to your network, and then before you accessing the internet, it'll give you a page. So those are used, like I mentioned, in public places such as hotel rooms and airports, etc., etc. On a private network, you can open File Explorer or Windows Explorer and drill down into the network group to verify that the network resources are available. So on those private networks, you may be able to look into the network resources and even connect to them if they are not secured with credentials, but you can actually connect to them with credentials as well. To view and change the network security settings in Windows 10, you can open up the setting app and click the network and internet and click change connection properties, and then either public or private, and that's how you're going to change the security settings. If you if you miss this pop-up or some reason you forgot or you don't remember what you press in this pop-up, you can still go and change it in Windows 10 as well as Windows 11 as well. In Windows 11 still have this option as well. For wireless connections, view the status of the connection, open control panel, and open network and sharing center. So to view the status of the connection, you go to control panel and then the network sharing center on the Windows machines, and click change adapter settings, and the network connections window appear. And in the network connections window, right click the Wi-Fi connection and click status, and in the Wi-Fi status box, click wireless properties, then select security tab, and to view the security key, you can hit the show characters and it'll show you the security keys. So you can actually check the security keys, and you can plain text read it, the security keys on a Windows machine by going through these steps. If you have a problem making a network connection, you can reset the connection. To do that, open the network connections window and right click the network connection, select disable from the shortcut menu, and then right click the connection again, and then you can re-enable it. And I can show you that on the next page right here. So you basically click on here and you can right click, you can go to properties, and in properties you can actually see the network security key as I mentioned here, right? And then if you want to enable and disable, you can right click on that Wi-Fi network and you can go enable disable right here. See right here, disable, connect, disconnect. You can use diagnose, and all of those options try to troubleshoot the Wi-Fi connection issues. Creating a dial-up connection. So bare bones installation steps that you need to take, the basic, in other words, basic installation step you need to have in order to make that dial-up connection is to install internal or external dial-up modem. So if you have a dial-up card, make sure all the drivers and software associated with that card is properly installed. Plug phone line into the computer modem port and the wall jack, so that it is connected to the PSTN or wireless or the telephone network. Open network and sharing center window, click setup a connection or network, select connect to the internet, set up a broadband or dial-up connection, click next and click dial-up, enter the ISP information, click create. So that's how you create a bare bone installation steps. However, you may remember in Canada and United States when we were kids, at least when I was kid, there were other dial-up method of connecting such as AOL. AOL was very popular. It's called America Online. And I remember those CDs coming to my house. And in Canada, we basically install that CD. As long as you have a dial-up modem, it will going to install all the drivers and software. And now the AOL software going to do all of these items that you have to do otherwise manually in its software itself. So your account will be associated with the AOL. AOL will be acting like as the ISP. And that is the one giving you the internet connection. So remember the AOL connection, so you don't have to go through these steps. So a ISP created custom software will do all of these things for dial-up connections if you were to use such software such as the AOL. To use the connection, you basically click your network icon in the taskbar, select the dial-up connection, click connect or click dial, and you will hear the modem dial-up and ISP dial up the ISP and make the connection. So with AOL, that would be you opening up the AOL software, and then you're going to click connect, and it'll automatically going to connect it, and you're going to hear these sounds again as it connect to the AOL internet system. So again, remember, these are the basic bare bone installation steps. But with companies like AOL in the past, in Canada and the United States at least, we had, when growing up as kids, we used to just use the AOL software to connect without going through these steps. So if you were to go through those steps, this is what it looked like. So you will have a window like this from the Windows 10, for example, and you will have to enter the username and password and what number to dial. This number may be your own telephone number, or it could be a specific number that provided to you by your service provider, and you basically enter that information, whatever given to you by the ISP, and then that's how you connect it. But again, if you have a software like AOL, you don't need to do all of these things, because those AOL and other specialized software are going to take care of that part of the equation. Functions of a small office, home office router, also known as a SOHO router. A typical SOHO router usually combines these features. As a router, it stands between the ISP network and the local network, routes traffic between the two networks. So it's basically sitting like a middleman, basically like a demarcation point, but it's like a middleman, right? So as a router, it stands between the ISP network and the local network and routes between the two networks. As a switch, because it will have a switch built into it oftentimes with a show host, it manages several network ports that can be connected to a wired computers or other network devices. So it will have switching capabilities already built into the router, enabling you to use it as not only as a router but also switch. So basically it's a router switch combination. This is very common even in modern day, in 2024, because 2022, because ISPs oftentimes provide those router modem combinations. As a DHCP server, all computers receive their IP address from this server. So it will also act like a DHCP server. They should be actually highlighted here, and therefore it will it will allow that device to hand out ISP automatically to anybody who is requesting a DHCP IP. So basically, whenever a new device gets connected, it will receive an IP address, subnet mask, and all the information it needs, DNS information, for example, so that it can directly connect to the internet without doing much technical work. As a wireless access point, also known as WAP, a wireless computer can connect to the internet, or wireless device can connect to the internet directly through this type of SOHO router switch combination device. It may also have a firewall that will block unwanted traffic from the internet and can restrict internet access for local device behind that firewall. So these type of SOHO routers also have firewall capabilities. And if the router is used as an FTP, also known as file transfer protocol server, you can connect an external hard drive, and FTP firmware on the router can be used to share files with network users. And some of these SOHO routers, the FTP is not the only thing you can do by connecting a external hard drive. You can also connect things like printers to that USB port, and it will make the USB printer a network shareable printer, for example. And these type of SOHO routers also support various routing and switching functions sometimes. Those include the QoS, DMC, VPN support, etc., etc. QoS stands for quality of service, which I will discuss a little bit in my future slides. But that the SOHO router is like all-in-one package. So that's how you can look at these type of routers. So they provide routing capabilities, switching capabilities, DHCP servers, WAP capabilities, firewalls, FTP, and few other features. Basic router configurations. Physical location considerations. So place your router in a secure area. Even in a home environment, you should think about the physical security and accessibility. In business environments and enterprise environments, typically these type of devices are located inside a cabinet or a secure room. But even if you're installing in a home environment, you should think about physical and security and accessibility. The reason for being, let's say you have kids, right? You don't want your kid to pull on the wires and your router. That's pretty bad. This is actually applied to your Shoho, the router modem combinations as well. Any type of critical network infrastructure device should be placed accordingly. Think about that, the physical security. If the router has external antennas, change orientation for better performance. So not all routers will have external antennas, Wi-Fi capable routers. Some of them are built-in antennas, but if you have external antennas, think about how you can orient them and check the different orientation until you get the best performance out of it. External antennas may be extended with cables to mount outside a cabinet. So especially in a small business environment or business environments, you may also enterprise environment, you may want to put the router inside a metal cabinet, but then you put the antennas outside the metal cabinet, or you're going to have access points everywhere in your network anyway. That way you can communicate Wi-Fi signal properly. So external antennas on home routers in this particular situation, you can extend it using just cables, right? So in the enterprise and business environment, I would say we will be using access points. Those are different types of different way of getting Wi-Fi signal to different floors and different areas of your building without the need to pull a really long antenna cable. It's going to be using Cat 6, Cat 5 cables, which I'm not going to focus too much today because A+ certification program does not require you to know that information. If you want to learn about that, I have more than enough information posted on my YouTube channel. Again, you can check that out. So before start configuring features within the router, please check for firmware updates. This is one of the things that some people forget to do, especially home users. They get a basic router and they're excited and they plug it in and everything works and they're happy. But unfortunately, major firmware releases can dramatically improve the performance and may also include new features. So why would you want to miss out on those things? So before even you start configuring anything on a brand new router you just purchased from the store, check for any any firmware updates available at that time. So any computer equipment, this is actually applied to any computer equipment, it is recommended to check updates for firmware and software before going in depth of into configurations, because even configuration methodologies and the software may have changed as a result of these updates. Configurations options depend on router manufacturer, model and firmware version, but the following features should be taken into consideration when you are looking into configuring a basic router. That includes local login username and password. Please change it, because right out of the box, most of the time those default username and password going to be like admin or Cisco admin or admin Cisco, something very common that every router will have the same. So please change those defaults for increasing your security. Configure the DHCP server. That includes creating those pools and reservation IPs. Some home routers already have DHCP pools created, enabled, but you can change the configuration any way you like, right? For example, you can divide sometimes even that pool into different pools within your DHCP server. And some home routers have the DHCP server turn off by default, so you need to go in there and turn it on anyway, so might as well configure it the way you want it. MAC address filtering, which is a security feature you may want to implement at your house or in your business to secure your wireless network especially. But MAC address filtering can also secure your wired connections as well, because that can block certain MAC addresses or prevent anybody from just accessing your network, because of it's going to be using MAC addresses to decide whether the end device should receive an IP address or not, or even intermediary device should receive an IP address or not. Consider changing default Wi-Fi settings. So if a default WLAN or wireless LAN is turned on, which is the case in some router modem combinations that you get from your ISPs, I would go to your router modem device, which is a modem with routing capabilities, right? And change the router's portions, Wi-Fi, default Wi-Fi settings, so that you have a much more secure Wi-Fi connections. So there are different types of settings, WAP, WPA2, etc., which I have already covered in my YouTube channel for advanced CCNA network engineering lecture series. So I'm not going to go into depth right now here. So if you want to know more information, again, go back and check my YouTube videos. So for now, just keep in mind, you need to think about changing those default Wi-Fi settings. You can apply the quality of service or QoS settings. So what that basically doing is, if you have no QoS, you're going to end up in a situation where all the data are going to have the exact same priority. So as a result, critical data, entertainment data, normal data, and web surfing data all going to get an equal share when it's going to go out of your network or come back into your network. So the communication of normal data to critical data all going to be the same. But with the implementation of QoS, what's going to happen is the bandwidth will be prioritized based on what the data are going to be. So the normal data will have a little bit more, entertainment going to have a little bit less, and critical data going to have a lot more. And the web surfing data, sometimes some of the data packet maybe get discarded as a result of the other important assigned data being there in creating congestion on this network. So if all of these data try to leave and enter the network, all of this data is communicating and using up bandwidth, the web surfing data will in this situation get the least priority. And that is a good thing actually, because websites access web surfing is not time critical. But things like VoIP is time critical. It's very time sensitive, because if the VoIP packets are delayed, it's going to create jitter. So that's all you need to know about that. Like, just learn that how to implement the QoS based on your specific router manufacturer, model, firmware, and where to go, and just click around and find this information and make sure that you know how to set it up. And you can refer to your manufacturer's manual on how to set it up a proper QoS when the QoS is supported by your router. Set up universal plug and play, also known as UPnP, that also allow you to quickly connect wireless net devices to your network. So your wireless router can connect UPnP enabled devices by setting this thing properly. So most routers will come this enable right out of the box, but you may have to set up a few things before get it operational. Most routers comes with firewalls and configure it based on the needs. So just like a SOHO, the router modem combinations, one that I discussed previously, most routers also comes with a firewall built into the router, and you should configure it accordingly. Again, I'm not going to go into depth of firewall configuration, port forwarding, port blocking, etc. today, but keep in mind these are the options that you have. Configure additional features if needed, such as the USB hard drives, printer shares, access points. As I mentioned before, access points are basically like a wireless antenna, but it can be placed anywhere in the building, and access points basically allow much more flexibility, especially for enterprise and business environments. The other one you may want to configure is a DMZ, which is a demilitarized zone, and many other options if it is available on your router. So those are the things that you need to think about. Other router security features. A router's firewall can examine each message coming from the internet, and you can decide if the message is allowed into the network or not based on the router rules and configurations. A message is directed to a particular computer and to a particular application running on that computer, and the application is identified by a port number, also called a port or port address. Routers offer the option to disable or close all ports, means no activity from the internet can get in. You must specify exceptions to this firewall rule in order to allow unsolicited traffic from the internet. Exceptions are allowed using port forwarding or a DMC. So that is the basic security features associated with how firewalls operate. Again, I'm not going to go into depth of these things right now. I'm just giving you a broad overview that is needed for your A+ certification exam. So the port forwarding, which I mentioned briefly on my previous slides, is when a firewall receives a request for communication from the internet to a specific computer and port. The request will be allowed and forwarded to that particular computer based on that port forwarding rule. Tips when using port forwarding includes you must lease a static IP address from your ISP. Actually, I disagree with this point. I haven't been using a static IP address at all, but I do port forwarding in other applications. But this is what typically, yes, you need you must lease a static IP address to do a proper port forwarding, but there are ways to get around it. For port forwarding to work, the computer on your network must have a static IP address. For example, a web server, right? Static IP address, that is definitely a requirement. Using port forwarding, your computer and network are more vulnerable, however, because you are allowing external users directly into your private network. So the port forwarding is typically used by devices such as the web servers within your LAN, for example, right? Remember, we put the web servers in demilitarized zones because it is exposed to the public. DMC, which I briefly mentioned again previously, a DMC or the demilitarized zone is a computer or network that is not protected by a firewall and it is exposed to the public. So if having problems getting port forwarding to work, you can put your whatever the device that need to be exposed to the internet onto those DMC zones. DMC zones would be less desirable in terms of security to port forwarding. Port forwarding would be a little bit of better than DMC in terms of security, but that's another option available. Content filtering and parental controls. So the routers normally provides a way for employees and parents to limit the content computers on the local network can access on the internet, and can apply to specific computers, users, websites, categories of websites, keywords, services, time of the day, and day of the week. Again, I'm not going to go into any depth of these things because reason for that is I will do a completely different lecture series on network security and next generation firewalls on a later series, not right now. So keep that in mind. For this A+ certification program, you don't need to know how to configure, for example, Palo Alto next generation firewall. You don't need to know that. What you need to know is that these things exist and how basic functionalities of those work. It's critical thinking here, right? So it's about like common sense. That's what the A+ certification exams actually trying to test you. So criteria for filtering can draw from blacklist, which are lists that cannot be accessed, or whitelist, which are lists that can be accessed. So again, those are part of the next generation firewalls and firewalls. Deep packet monitoring or deep packet learning and sniffing is another thing that goes in with this kind of next generation firewalls, which I will discuss on a separate lecture series. For now, just remember these things do exist. Basic modem configurations. So now we're going to switch gears to modems. So the modems includes the cable modems and the satellite modems, because remember the fiber optics or optical fiber have a ONT, doesn't have a modem. Remember that? So that's right. So the modems are typically, we are referring to cable satellite modems, and also the ADSL modems as well. And they're configured typically by your ISP to work with their system. So your internet service provider would be configuring it before they handing over to you. But you can go ahead and purchase compatible modems from a third party. If you do that, then the modem serial number and other data must be registered with your ISP or it won't gonna work. So for example, I can go into the internet and maybe buy a brand new modem for whatever the reason, even though I get a modem for free, that would work with Showcable, which is who I'm with right now. Showcable is the internet service provider for my house, and I'm in Canada, and the Showcable is a Canadian ISP, and I can actually get a Showcable compatible cable modem, and I can contact Showcable and they can register that modem as part of my network, and then that can be used to access the internet. Most home use and small SOHO, small home office modems, are modem router combinations. So most home use and SOHO modems are modem router combinations, as I mentioned before. So in that case, you need to follow the guidelines previously discussed on router configurations, on how you can do the router part of configuration there, or you can do what I did, because I also got a modem router combination device from Showcable, but I requested the ISP to place the modem in bridge mode. So what that means is basically they removes the routing capabilities and features from the modem router combination box, and allow you to add your own router behind the modem without creating a double NAT situation. So you may ask the question, if you never heard the term NAT or double NAT, what is double NAT situation? Again, if you haven't learned or went through my lectures on CCNA network engineering program, you probably never heard that term. NAT stands for network address translation. NAT is used by IPv4 to conserve IP addresses, because IPv4 addresses are running out. What NAT's gonna do is, whatever inside your LAN or local area network, the IP addresses not gonna be directly seen by the outside networks. The outside networks has to go through the NAT translation process in order to access the devices within your network. So if, for example, you may have an IP address 192.168, so 192.168.1.10. The person who is on the outside of your network not going to see 192.168.1.8. Instead, the person on the outside going to see your external IP address provided by your ISP. It could be 209.35.65.195 or something like that, right? That's what they're going to see. So then what NAT going to translate your local area network to the wide area network, so they can access it and you can access them. That's the easiest way to describe that. NAT is the process of internal IP address translation to external IP addresses for communication across the internal and external. However, if you put two modems, two routers right behind each other, that's going to create a double NAT situation, unless you specifically stop one of those routers from creating a NAT. What that basically means, the router act like a NAT and the second router gonna act like a NAT, and the NAT gonna create double NAT. So so basically, because you have a router modem combination and it is doing routing and NATing there, which is provided by your ISP, and you put another router right behind it, now you have two NATs. That could create latency issues, that could create networking complexities, etc, etc. Latency is one of the biggest problem with double NATing. So that's what I meant by double NAT. So by bridging your router plus modem combination, asking them to put them into bridge mode, your router modem combination effectively act like just a modem. So the routing part is gone. So that way you can add your own router without creating the double NAT situation, because now there are no NATs associated with the router. So it's all going to happen on the modem. It's all going to happen on your router. However, not all ISPs and all service plans will support bridge modems as per customer, client, and ISP agreement. So depending on who's the ISP provider, in my case, they do support that. I have this exact same modem, actually. This is this type of modem, and I have the cable coming in from Showcable, and I only use one of these ports. because only one of those ports are active. Rest is now basically disabled because it's in bridge mode. So it goes from here and convert that signal, and now I have a one single connection out, RJ45 out, and that's going to connect to my router, so that I have more flexibility in how I manage my LAN, right? So that's something to think about. Other networking devices we are not going to cover today includes the access points, which I mentioned a couple of times, Power over Ethernet, also known as PoE. That includes the PoE switches, injectors, and PoE enabled devices. So devices include things like the security cameras, for example. Injectors are devices such as like this one. What that's going to do, actually, you don't have a PoE enabled switch. In that case, this will be going to sit between the switch and your PoE enabled device, and it's going to inject power to the device so that the device can power on through the network cable. So what the PoE is doing, exactly what it described. It sends power over the Ethernet cable. Switches and hubs. So the switches are the one that we commonly use now in 2022. Hubs are legacy devices that are almost never used in 2022 on a new installation, but you may come across in the field. Wireline Ethernet looks like this type of devices where you can plug it into wall into power, and then it'll create a mesh network by bouncing off each other, and eventually going to bounce into the your router, and as a result they create a mesh type of network using the wireline Ethernet. But it is wireline Ethernet, not mesh. Mesh is different. So there's another one called Wi-Fi mesh networking kits. They include like something like this. They're going to bounce against each other like this, and then in between, and going to create a mesh, providing better wireless coverage, especially for home use. But there are also enterprise mesh network as well. Again, I'm not going to cover any of these other networking devices in depth today, other than the one that I'm going to cover, like the basic ones. These are some of the items that do exist, you should be aware of. Setting up a wireless network. So basically Wi-Fi, which is stands for wireless fidelity, standards have evolved over the years, and technical name is the IEEE 802.11 standard, and you will probably heard about ABGN and AC associated with that. So that is an International Electrical and Electronics Engineers Association, International Electrical Electronics Engineers Association, and they are the one who decide those standards. So all consumer use wireless standards are 802.11 standards. Those standards includes the A, which is the range up to 50 meters and the radio frequency of 0.5 gigahertz, 5 gigahertz. The B, which is a range up to 100 meters with a radio frequency of 2.4 gigahertz. G, the same range and frequency as the 802.11b, the one above, but with faster speed, now supporting up to 54 megabyte per second. And 802.11n uses either 5.0 or 2.4 gigahertz frequency with an indoor range of up to 70 meters and an outdoor range of up to 250 meters. That can, achieve that kind of a range. That is pretty good jump from the G to N. And 802.AC uses 5 gigahertz band frequency and has the same range as 802.11n. So same as this range, except the performance stays stronger at the edges of its reach as a result of using 5.0 gigahertz. So these are the basic fundamentals you should understand about Wi-Fi standards. So when it's come to setting up a wireless network, you also need to think about the security and encryption. Security key, which is the most common and effective method of securing a wireless network. Basically you create a key, security key, and that key is required for someone to get access to your wireless network, to get connected to your wireless network. The data is encrypted using an encryption standard, and use the router firmware to set the security key, and the best to enter a security key that is different from the password you use to your router utility. So to log into your router, you should have a different password compared to the password that you're going to use for your wireless network. That shouldn't be the same, because that way, like if you this type of security, wireless security key is something that you're going to be handing out to your users, so you don't want to have the same password on your administration of your router. So keep that in mind. Set encryption. So the main security standards for encryption of 802.11 wireless networks includes the WEP, WPA, WPA2, and WPA3. Now, WEP, which is a wired equivalent privacy, is a legacy method, and it is no longer considered secure because the key used for encryption is static and easily crackable. The only reason why you would implement WEP if you have really old devices that require WEP type of security encryption, because it cannot handle the other options available. WPA, which is Wi-Fi protected access, also called the TKIP, and is stronger than WEP because encryption keys are constantly changing as it connects and communicates. The WPA2, also known as the 802.11i standard, is the latest and best encryption standard currently widely adopted in the industry, while the WPA3 offers better encryption and additional features over WPA2. However, some devices, even in 2022, may not be able to handle WPA3. So I would typically go with WPA2 whenever I have to set encryption for any of my wireless devices, and I always try to go up here instead of going down here. So I never have used WEP or WEP, wired equivalent privacy, because it's no longer in use. It is considered as a legacy. Change the default SSID and disable SSID broadcasting. So the service set identifier, also known as SSID, is the name of the wireless network. So if somebody wants to connect to your wireless connection, when their receiver or the device that's going to grab that transmitting signal, look for any wireless network availability. Your wireless network name that they see is actually the SSID. SSID is the name of your wireless network. You can look at that way. So not considered a strong security method because software can use to discover an SSID that is not broadcasted. However, by stopping the broadcast of your SSID, it requires an extra step from the user's side in order for the user to connect to your wireless network. For example, in my house, I have a wireless network. I decided I'm not going to disable SSID broadcasting. So anybody can check any available wireless connections near my house. And if they see my wireless connection SSID, and they can try to connect to it, but they need to know the passphrase, but they still can see it. So it easily can get that wireless SSID information. But if you hide it, what's going to happen if you disable the SSID broadcasting? They are not going to see that. So they have to know not only the wireless network passphrase, but they also have to know the SSID in order for the network to get connected to, right? So that's why the stopping the broadcast or disabling may increase the security a little bit, but keep in mind it is not considered as a strong security measure, because there are many tools, many software that easily can figure out what your SSID is, even if it is not broadcasting. So keep that in mind. It is not considered as a very strong security method at all, but it is one more step you can do to secure your network. And obviously you should change your default SSID that comes out of the box. So if your service provider give you a router modem combination, your SSID may be a random common SSID. I would highly recommend changing that, because it's easy for you to manage, it's easy to you to identify, and it also make it secure as well by also changing the passphrase as well. Select channels for the WLAN or wireless network. Channel is a specific radio frequency within a broader frequency. So that's the easiest way to explain a channel. A channel is a specific radio frequency within a broader frequency. In the United States, 11 channels are available for wireless networks, and same in Canada, it's 11 channels are available for wireless networks. If experiencing interference, you can set each network to a different channel. Selection of correct channel is very important if you are in an apartment complex situation. So if you're in an apartment complex and each person in the apartment create their own little wireless network for their apartment and they're very close to each other, you may end up getting interference. Another reason why you may want to change this, if you have multiple IoT devices, and if you have other devices, other wireless devices in your house, that may interfere against each other sometimes, not always. So there are certain situations, the interference may create, even between different wireless devices, there may be interference. Microwaves, for example, microwave cooking devices can also create interference as well. So you can change the different channels to try to mitigate some of those interference, not all, but some of those interference, to try to reduce those things. Again, I'm not going to discuss interference and wireless network, how you can pick those and what is the best way to pick it, and at a very advanced level, because for A+ certification program, you do not need to have that kind of knowledge to do better in your exams and quizzes. Again, this is going to be a separate lecture that I will be posting, lecture series that I'll be posting to my YouTube channel. Radio power levels, that's another thing that you can play with or change on WLANs. So some high-end access points allow you to adjust the radio power levels to reduce interference or limit the range of the network or to save on electricity. But keep in mind, these options are now becoming more and more available on consumer devices as well. So if you don't know what you're doing, keep it at default. But if you want to just play with it, maybe play with it and get much better performance out of your device. So these type of things are typically associated with access points and enterprise business grade devices, but newer version of routers and modems, router combinations do have radio power level control built into their firmware as well. Wireless QoS. For wireless devices, you can improve QoS by enabling WMM, which stands for Wi-Fi multimedia. When WMM is enabled, the wireless access point will prioritize wireless traffic for audio, video, and voice over other types of wireless network traffic. So basically, it's a one-click solution for most home users as well as some small business users. Wi-Fi protector setup, also known as WPS, that generates the SSID and a security key using a random string of hard to guess letters and numbers. It is done by the computer chip itself in your router, and the WPS might be a security risk if not managed well. So turn on auto disable so that the WPS will be disabled after a few fail pin entries. So keep that in mind. So WPS do have some security vulnerabilities. So to mitigate that, turn on auto disable on WPS. That will disable after multiple pin entry failures. Virtual private network. So I'm going to switch gear a little bit now again. So this time we're going to talk about VPN. So virtual private network, or VPN, extends private network across a public network. It allows users to communicate as they are connected within a LAN, even though they are in a remote location. So for example, I could be in Calgary and my office could be in Burnaby, BC, and I can connect to my office resources such as network drivers, FTP files, etc., printers even, through a VPN, just like I'm sitting in a BC, Burnaby, BC office, even though I'm in Calgary and the office is in Burnaby, BC. So basically, virtual private network allows the users to communicate as they are connected within a LAN, local network, local area network. Secure communication using a technique called tunneling. So the VPN use a technique called tunneling, or VPN tunnels, to basically build a virtual infrastructure on top of the existing public network. So basically, a tunnel you can look at as like a LAN that is running on top of a public on the public network. Implementation requires managing softwares, routers, and or dedicated servers. So you may have to buy VPN enabled routers or VPN appliances that you have to be installed at your office, or your enterprise environment, or at your home, in order to create this type of VPN tunnels. As the name suggests, the VPN connection is virtual, and it uses the existing public infrastructure. So VPN connection is a virtual connection that virtually creates a private LAN network on the public infrastructure by using those tunneling methods. So tunnel is type of a virtual isolated network. As a network engineer, when creating VPN, please follow organizational procedures, network administration guidelines, and directions provided by the manufacturer. Again, if you want to learn about network engineering, go back to my YouTube channel and learn about the CCNA programs, and CCNA 1, 2, 3 will give you a lot more information than you need to do some advanced level network engineering stuff. Okay. Creating a VPN connection using Windows. So you can actually create a VPN network right on your Windows desktop computers, like with the even Windows 10, Windows 11 home and professional versions. You don't need Windows Server or anything like that. And for that, the general step to do connect to a VPN is in a network and sharing center, in the Windows network and sharing center, click set up a new connection or network, click connect to a workplace, set up dial-up or VPN connection to your workplace, and click next. In the connect to a workplace box, you're going to select use my internet connection or VPN, enter IP address or domain name of the network, name the VPN connection, and click create. Whenever you want to use the VPN connection, click the network icon in the taskbar now. Once you have done all these steps at the beginning, these two steps, and in the list of available networks, click VPN connection and click connect, enter your username and password and click OK. Problems connecting to a VPN can be caused by wrong authentication protocol used when passing the username and password. In that case, click the properties of the VPN connection to configure the security settings. So if you go to the next slide, we will see that the configure VPN security settings shown here. It's basically under VPN connection, under security. You can change that information. Again, I'm not going to go into depth of these things right now because it's not needed at this point. Dynamic and static IP configurations. So computers use IP addresses to find each other on the network. So IP addresses are like a home address on a street, right? The street can be your LAN, local streets can be your LANs, your network, and the IP addresses are like the address of a home, but except for these computer network connected devices. An IP address is assigned to a network connection when the connection is first made, and can be a 32-bit string when written as 4 decimal numbers called the octets and separated by periods, such as 192.168.1, etc., etc. Or it could be a 128-bit string written as 8 hexadecimal numbers separated by colons. Those could be like 84 colon EB, well, not 84, like 10 colon EB, like X. It's a IPv6 address. Most networks use 32-bit IP addresses in 2022 even. Those are defined by IPv4, which is called the Internet Protocol version 4. Some new networks use both 32-bit addresses and 128-bit addresses. 128-bit addresses are defined by IPv6 standard, also known as the Internet Protocol version 6 standards. Again, if you want to learn advanced concepts associated with this, I have already covered on my previous lectures. A host is any device on a network that requests or serves up data or services to other devices. Keep that in mind. So if somebody asks you what's a host is a device on a network that requests or serves up data or services to other devices. So basically it's like a device and connected to a network is a host, pretty much. To communicate on a network or the internet, a host needs its own IP address, for example 192.168.100.4, a subnet mask, for example 255.255.2550, so that would be a subnet mask, the IP address of the default gateway which is used to send data to other networks, so that would be the IP address of your router typically, or the router's port. So that's what would be the default gateway. Default gateway always going to be the router or the router port address, IP address. The IP address of one or more DNS, also known as domain name system servers. Those actually could be IP address, or sometimes you can give DNS to a system via actual name itself too. But typically it is the IP address of the domain name server. Actually, I misspoke. No. The IP address of typically almost always it's going to be the IP address for DNS as well. The domain name system will use the IP address, not the name actually. Yeah. The above information can be manually assigned to a computer's network connection. The computer's IP address would then be called a static IP. So a static IP address or static IP is a situation where you don't use the DHCP server to automatically obtain the IP address, subnet mask, default gateway, and DNS information. Instead, you're going to manually assign that information that then become a static IP address. This information can be requested from a server on the network, and that's where the DHCP come from. And the DHCP stands for Dynamic Host Configuration Protocol, which is a type of server, and IP address received if through this type of process is called a dynamic IP address. So if you plug in a device to a network and it automatically obtains the IP address, subnet mask, default gateway, DNS, etc., that is getting that information from a DHCP server. And you have now received a dynamic IP address. It is dynamic in a sense because it is randomly assigned, and when you leave the network and after a while, that same IP address can be leased by this server to another device. So that's why it is dynamic. With static, if you set up all of this information, even if you unplug and plug back in, it's always going to be the same IP address because you have statically assigned, right? And there are some rules associated with how you can statically assign and what addresses you can statically assign. If you have already a DHCP set up within your LAN network, I'm not going to go into detail again because it's not needed for this particular class. To configure dynamic and static IP addresses, open Network Connections window in Windows, right-click Network Connection and select Properties. On the Properties box, click Networking tab, select Internet Protocol version 4, and then click Properties, and default settings is the dynamic IP addressing, and then you can change it to static by following use the following IP addresses. Like you can enter the IP address, subnet mask, and default gateway. And if your network administrator has given you the IP addresses of DNS server, select use the following DNS server addresses and enter up to 2 IP addresses, and that's how you can set up all of those things. Now, if you want to learn more, check my CCNA videos on the YouTube channel, and that will get you some more information about all of those things and how those IP systems work and addresses work, etc., etc. So here this shows exactly what I was talking about. So you go to the internet connection, you go to the properties, you select the IPv4, and then you're going to change this from obtain an IP address automatically to use the following IP address, obtain a DNS server address automatically to use the following DNS server addresses, and you're going to enter those information. So that's how it works. Managing network adapters. So a computer makes a wired or wireless connections to local network using a network adapter. It might be a network port on the motherboard or a network interface card, also known as a NIC. It may also be an external device connected via a USB port. So if you have especially those thin small lightweight portable laptops, they may not even have a network port available built into the motherboard. You may have to use a USB port with a special adapter that have the RJ45 connection on the other end. Features to be aware of on an adapter includes the drivers of a NIC that uses the Ethernet speed and the MAC addresses. So the drivers, make sure you have the proper drivers installed, especially with the USB network connections, but also even with the NIC cards, make sure the drivers and the software is properly installed. Ethernet speed includes the full duplex, which sends and receives transmissions at the same time, and half duplex, which works only in one direction at a time. The most common error in network engineering and network architecture is that a mix match of full duplex and half duplex, which will bog down your network. So again, I have extensively talked about this on my CCNA lectures you can watch, but for now just remember the full duplex, half duplex, whatever you are using, it should match. In modern day, almost every system should be in full duplex, in my opinion. MAC addresses, every network adapter has one, which is a 48-bit unique number hard-coded by the manufacturer. You may end up in a situation, sometimes in a very rare cases, where you end up with two NICs or two connections with the same MAC address. In that case, you can use MAC address spoofing to either use it or use a different network card. There's very rarely, it's a 48-bit unique address, so it's very rarely you might end up in a situation where you have the same MAC address in two different devices on the same local area network, but otherwise it should be okay. And the MAC address is only used in local area network and not in WAN or other networks, so keep that in mind. Other few things that you should know about includes the status or status indicator lights. Those lights are pretty typically located just underneath the port, and they blink in green when it is a full duplex gigabit connection, and they typically blink in amber or orange when there is a connection issue or it is not full duplex or not gigabit. So those are really good way, those LED lights are really good way to visually check your network connection. Wake on LAN, which is a method to wake up the computer when it receives a certain communication on the network. For onboard network interface card, you must enable Wake on LAN in the BIOS or UEFI. On other network interface cards, there are some configurations that you need to do for Wake on LAN to work. And Wake on LAN is mostly used in enterprise and business environment, but it is also available in consumer environments as well. So basically you have a computer with the power plugged in but shut down. The specific certain signal that you can send it to the LAN card will boot that computer up or the server up. So these are very commonly used in especially servers, so that you can get at least the out of band connections working by when the server goes down. Quality of service or QoS, which I have covered already, that will give you the ability to control which applications have priority on the network and must be configured on the router and the network adapter of each computer based on how your network configuration is done. So that's some of the things that you need to look into. So here's an example of a Wi-Fi network card by TP-Link, and here's another network card that is a wired network card with two connections on it. Typical Windows network commands. So we are getting closer to the end of this lecture. So now we're going to look at some basic network commands that are very useful for troubleshooting network issues, but not exhaustive, complete list of network commands that you should be familiar with as you become good at being IT technicians. Okay, these are basic network commands that you should be familiar with according to A+ certification program. So the first network command we're going to look at is the ping command. The ping command tests connectivity by sending an echo request to a network connected device. So what it does actually test the connectivity by sending an echo request to a network connected device from the device that you're pinging from. This is actually the very first test that I would do when I have network connectivity issues. At work, at home, everywhere, the pinging is the first thing I do. So if the remote computer is online, it detects the signal and is configured to respond a ping. So it will respond back. So if this is a very key piece of information. If the remote computer is online, detects the signal, but it also has to be configured to respond to a ping, it will respond. So just because of ping doesn't get returned doesn't mean that there is a network connectivity problem, because there are ways even in firewalls that you can block ping commands to prevent ping flooding, which is a type of attacks that happen on computer networks. So if the remote computer is online, whether it's a Google server or your own servers, it detects the signal and it is configured to send a ping back. It will send a ping back, right? So use ping to test for connectivity or verify DNS is working, and the ping command format is basically ping, and then you can put the target at the front. So likewise, I said, you can even verify the DNS testing too. You can go ping google.com or ping sanuja.com, and if it send a ping back, that also shows that your DNS also working. But keep in mind your whatever the site you're pinging. For example, if you try to ping sate.ca, which is a Southern Alberta Institute of Technology in Calgary, the ping command going to return timeout, because their servers are set so they won't get ping flooding, and it won't return a ping signal echo request back. So keep that in mind. Ping is a really good way to test connectivity. It's very easy. You go to your computer and start pinging an IP address or a domain name. So ping sanuja.com or ping 192.168, etc. I will show you on the next slide. And but however, the end device has to be set so that it won't block those ping returns. So here's an example of a ping commands. So in this example, we are pinging 192.168.1.69. So the ping test for the connectivity using, you can do it using either IPv4 and IPv6 address. And in here, we are using an IPv4 address. So if the remote computer responds, the round trip times are displayed on your command prompt as well. So you can on the Windows machine, you can hit ping 192.168.1.69 and it'll come back those information on your screen. If you do ping-a, then you go 192.168.1.69, what's going to happen? The A parameter tests for name resolution. So use it to display the host name and verify that DNS is working. So that will actually test the DNS is properly working. Ping-t 192.168.1.69, what that T parameter is doing, it's going to cause the ping to continue until it get interrupted. So this is where it's going to have a continuous ping until you interrupt that pinging from happening. So to display statistics, you can do the CTRL break, and that you can stop pinging by pressing the CTRL plus C, and this will give you a continuous loop of pings to whatever the destination. In this case, 192.168.1.69. So 192.168.1.69 gonna get pinged continuously. Pinging the loopback address, in this case ping 127.0.0.1, which is the loopback address for IPv4. What that's gonna do, this loopback address 192.168.0.1 is referred to as a local computer, right? So if the local computer does not respond, you can assume there is a problem with the network connections configuration. So if you have a network connection configuration issue within your own computer, that means your end device itself, pinging 127.0.0.1, which is a loopback IPv4 address, can test that information. Again, I have extensively explained how loopback addresses and these addresses and these different pinging works on my other lectures, so you can go ahead and watch that on my YouTube channel. if you ping a domain, in this case like ping sanuj.com, what's going to happen, the host name gonna find out the IP address of the remote computer, and if the computer does not respond, suspect there is a problem with the DNS. So in here we are testing the domain name server. So on the other hand, some computers are not configured to respond to this type of ping, that will also fail the ping return. So keep that in mind. You can have a failure because there is a problem with the DNS, or you could have a failure in this type of ping because the other computer end device is not designed, configured to respond back to pings, right? Remember I mentioned that on the previous slide. So keep that in mind. Typical Windows network commands. And now this we're going to look at IP config. So we look at the ping first, and now we're going to look at IP config. So IP configuration or IP config command can display network configuration information, and it refresh the TCP IP assignments for a connection. And the IP config command format is IP config, and then you can put whatever different types of commands that you're going to be looking at. For example, you can put IP config /all, release, renew, display DNS, and flush DNS, and I will explain what they are on my next slide. So here is an example of that IP config. So IP config /all displays a network connections configuration information, including the MAC address. IP config release the IP address and the TCP IP assignments when the dynamic IP addressing is being used. So if you have static IP configured here, and if you enter the IP config /release, it's going to give you an error message. But if you have dynamic, or you're obtaining an IP address through DSCP server, in other words, the IP config /release will reset that TCP IP assignments. IP config /release 6 is the same version as this one, except for version 6. So this is version 4, version 6. IP config /renew, that what that gonna do, it releases a new IP address from your DSCP server, and you can make sure to you that release the current IP address before you renewing it. So you please enter the IP config /release, and then you're going to enter IP config /renew. That will get you a new IP address. And this is the version 6 IPv6 version of that, which is IP config /renew 6 at the end. IP config display DNS, what that going to do, display the information about the name resolutions that the Windows currently holds in the DNS resolver cache. So all your Windows end devices, such as your Windows servers, Windows desktop computers, Windows 10, 11, Windows 8, they all contain a local DNS resolver cache. And you can display that information by running the IP config display DNS. The reason why we have this cache is to speed up the process of DNS lookup. IP config /DNS flush basically flushes the name resolver cache, which might resolve a problem when the browser cannot find a host on the internet. So if you have a issue where your web browser cannot access a particular website, for example, you can run the IP config /DNS flush DNS to try to see if that's an issue with the DNS resolver cache. So next typical Windows network command is the NSLOOKUP. That's the one we're going to look at now. So the NSLOOKUP, basically a namespace lookup or name server lookup command that is used to test name resolution problem with the DNS servers. It allows you to request information from a DNS server's zone data, and the NSLOOKUP command format is NSLOOKUP, and then you can enter the target at the front. The zone data is the portion of the DNS namespace that the server knows about, and a reverse lookup is when you use the NSLOOKUP command to find the host name when you know the IP address. So reverse lookup is when you do the NSLOOKUP command to find the host name when you know the IP address. So you enter NS lookup and then you put the target IP, that's a reverse lookup. But if you do NS lookup and then you put the target's name, that's a forward lookup, like a regular NS lookup. But keep in mind, NS lookups oftentimes may result in timeouts, and that has to do with your network configuration setup. But I'm not going to go into detail and depth of that again, because that is not required for your A+ certification program. I'm actually covering more information in this lecture about network systems and network engineering side of things than what you need to know for A+ certification. Little bit, but I keep it as little as possible because you don't need to know anything more than that. So again, you don't need to know why these times out happen, but know that the times out do happen for your A+ certification exam. For example, in here, I try to look up nslookup sanuja.com, and what happened is it went through, it found the Manuja net, my internal network system, and it times out. So yeah, that do happen. Again, I'm not going to explain that. Just know the times out often happen with NS lookup. The next typical Windows network command that we're going to look at is traceRT. The traceRT, also known as traceroute command, can be useful when trying to resolve a problem reaching a destination host. The traceRT command format is the traceRT and the target. So the target can be an IP address or like a domain name. The command sends a series of requests to the destination computer and displays each hop out to that destination. So between your computer, which is trying to do this traceRT, and the destination, it's going to count those hops and going to display it. A hop happens when a packet moves from one router to another. Like for example, in here, we have a host and we have another host, and there are 3 hops in here. So there's a 1 hop, 2 hop, and 3 hop. So when this the device do a traceRT command to 172.31.10.0, it's gonna display 3 hops, 1, 2, 3. So that's what it means by a hop. You should know what a hop is, but you don't need to know any more detail than that. A message is assigned a time to live, also known as TTL, which is the number of hop counts it can make before a router drops the packet and sends an ICMP message back to the host that the sent packet. So keep that in mind. So a message contains something called a TTL, or time to live, which is the number of hop counts it can make before a router drops that packet. And if that drop happens, then it sends an ICMP message back to the host, which try to do the traceRT, saying that the packet has been dropped. So that's all you need to know about traceRT. That is a really good way trying to solve a problem when it comes to the point reaching a destination host. So here's an example of a traceRT that I ran on sanuja.com, which is my website. So on my computer at home, I ran the traceRT sanuja.com, and my computer has an IP address, internal IPv4 address of 192.185.255.33, and it's gonna send the request out, and then you can see that it is pinging my network, the outside network, through my router gateway address, which is 192.168.1.1. So that's the first hop, and that's the second hop, that's the third hop. So you have a bunch of hops all the way to 18 hops before the traceRT is complete. So each of these hops represent a type of a router. You can look at it that way, which the packet travels through. Now, one thing that you might ask, like, how do you know if a traceRT fail? The failures will shown typically as like this. Right here it says request timeout. So that star actually basically saying the time to live has expired, therefore the packet has been dropped. So that's an failure. This is a failure, another failure. Right here there's another failure as well. So that's the time to live. When it expires, it basically have a failure right there. So the next typical Windows network command that we're going to look at is the net commands. So the net command is several commands in one. So the most require an elevated command prompt window. So that means you need to be running command prompt in an administrative mode in order to run this. The previous commands, such as this one from traceRT, you don't need to have administrative privileges, but this one you do need to have administrative privileges. Net use command connects or disconnect a computer from a shared resource. Use the following command to pass a username and password to, in this example, blue light remote computer, and then map a network drive to /medical folder on that computer. For example, in here, net use, and then you're going to enter that, and then you're going to enter username and password, and net use C, and then it's going to map that drive to that. So this is just an example, by the way. So the net user command manages user accounts, and that is can be a useful tool in your Windows repository of tools. Next, another one we're going to look at is the netstat. The netstat stands for network statistics command that gives statistics about network activity and includes several parameters. The netstat command format is the netstat, and then you can enter different parameters associated with that netstat. The examples of that netstat command include just simple netstat that lists statistics about your network connections, including IP addresses of active connections, and then the netstat, and we will go with this piping command, which is 2 double arrows with the net log.txt. What that's going to happen is whatever displaying on the netstat window going to be output into a .txt file so that you can use it later. Netstat-b lists programs that are using the connection and is useful for finding a malware that might be using the network without your knowledge. And the -b switch requires an elevated command prompt. You need an administrative privileges. Netstat-b-o includes process ID of each program listed. When you know the process ID, and you can use the task kill command to kill the process. Again, you need elevated administrative privileges to run this. Netstat-a lists statistics about all active connections and the port the computer is listening on at the time of this command is being run. You want to learn more about these commands and these specific in different types of configurations, as well as advanced troubleshooting methods, please go and watch my CCNA videos on my YouTube channel. And those videos are available to you as different types of playlists, CCNA 1 playlist, CCNA 2 playlist, and CCNA 3 playlist. So I will leave the links in the description of this video so that you can go ahead and watch this. So in this A+ based lesson, what we are doing is we are doing a broad overview of network systems and basic configuration options. But in order for you to be a good network technician, you may need more information than that. In that case, please go ahead and check out my CCNA 1, CCNA 2, and CCNA 3 lectures that I have posted already onto my YouTube channel. And that's the end of this lecture. Please thumbs up this video and subscribe to my channel. And until next time, good luck with your exams and have a nice day.